Bismillahirrahmanirrahim. Assalamu alaikum everyone. We are going to conduct another video tutorial on signals and systems course. And in this video tutorial, I'm going to cover a different topic which is related to singularity functions and as well as time operations, right? And this topic includes the procedure that how one can actually express a signal, any given signal, into the singularity function. For example, we are given with this signal. In this graph, we are given with a signals graphical representation, and we are supposed to calculate or express this signal into the singularity functions or in terms of singularity functions. For those who are not aware, what are singularity functions? Singularity functions include step, impulse, and ramp signals, right? I've already covered about singularity functions. Furthermore, we are going to utilize the time operations or transformation of independent variable in this video tutorial. So I hope that if you are watching this tutorial and if you are trying to understand this topic, you need to understand the time operations as well, because we are going to use them in this video tutorial, right? So let's start our discussion. So we are given with this signal. This is just a graphical form, and we are asked to express this signal in terms of either step, ramp, or impulse, right? Wherever it is possible. So to start this expression of signal in terms of singularity functions, we need to start examining the signal from the left hand side, or from the minus infinity. Somewhere this is the time axis. We know that this is time axis, right? So we know that somewhere here it will be from minus infinity, and somewhere here it will be some plus infinity, right? So eventually the signal starts from t equals to -4. This is the point of t equals to -4, right? So at this point, signal is starting, and we are observing its behavior. Its behavior is like this. This is, so if I'm just going to draw its behavior, let me use a different color so you understand it. So this signal starts somewhere here, and if you follow this behavior is nothing but simply a ramp, a step signal, right? Because step signal is something like that. Only the difference, difference of the characteristics will be its time index. Normally, step signal starts at t equal to 0, but in this graph, the signal is starting at -4, right? So it is very simple to express it. Furthermore, one more important thing, usually step signal has certain amplitude, which is called step level. So in this specific example, this step level is 2, right? So we can express the signal very easily by just simply writing x of t. This is our x of t signal, and the very first behavior we notice in this signal is step, is u of t, but it is not simply unit step. It's rather advanced version of unit step, because it's starting from -4 points. So t plus 4 would indicate that it is a time advanced version of unit step. Furthermore, one more thing, its amplitude is 2, right? So just to revise everything, if you notice that original step signal should be starting from this point, right? But it is somewhere advanced about -4 unit, and its amplitude is 2. So that is why it is 2u of t plus 4. T plus 4 indicates that it is advanced by 4 unit. So I hope this is the first behavior that we wanted to understand, and we actually express this behavior. Now let's check when this behavior is going to change. Signal's behavior change at this point. This point is what? -2, right? This point, and its behavior is something like that. If I'm just going to draw. Again, at -1, this behavior will change, but I'm just trying to focus on the next change in behavior. And if I'm going to draw this complete line, it will look like this. right? And you know that this slant line is normally known as ramp signal, and this ramp signal is decreasing from negative side to positive, from negative infinity to positive infinity, and signal's behavior start at this point and signal behavior changes again at this point. So in x-axis, if you are going to notice, the horizontal units of this behavior is basically how much, 1 unit only, from -2 to -1. And vertical unit you want to just notice, because in ramp you need to notice both vertical and the horizontal displacement covered by the signal. So vertical displacement is around from 2 to 1, right? Signal is decreasing, so basically at this point its value is 2, right? This is the point, this value is 2, and this point its value is basically 1, right? So if you are trying to calculate its slope, its vertical axis is basically 1, or vertical distance is 1, and furthermore vertical axis is basically 1 and horizontal axis is also 1, right? Horizontal displacement is 1, so slope is basically 1. And in ramp the most important thing is its slope, right? Slope. Furthermore, its slope will be negative because it is decreasing, right? So if normally any ramp signal is written as ramp of t, and before ramp we put its slope. So in this specific case, slope would be simply -1, right? Ramp r of t is simply r of t, but this normally ramp starts at again points around at 0, right? At the 0, but this ramp is starting at -2, so that is why this is going to be -r t plus 2. Again, this ramp is advanced by 2 units, so -1 is the slope, and the ramp behavior is basically what, it's advanced by 2 units, right? So this is going to be the definition of this behavior, right? Let me just point it out that this ramp indicates this one, and earlier the part which we already discussed was basically what, 2u of, that was basically step signal 2 plus 4, right? And that part indicates for this behavior, right? Now let's talk about the next part. Okay, let me also write this behavior in the main equation, which is basically this one. So minus r of t plus 2, right? Now let's check the next behavior, and the next behavior, let me use a different color, it would be more easier to understand. The next behavior somewhere starts here, right? At this point at -1, right? And next behavior is also kind of ramp, but this time ramp is increasing. If you notice, this ramp is like this, right? And if I'm going to show you the horizontal units, the horizontal units is from -1 to 1, and the vertical units are from what, from 1 to 3, right? So if I'm going to calculate its slope, the vertical units is basically 2, and the horizontal units are also 2, right? So slope is going to be 1. Remember, the last slope was -1, and in this behavior slope is basically what? Slope is simply +1. So slope is changing from -1 to 1, right? If you want to change something from -1 to +1, that means change should be what? +2. That is only possible way, right? So if I'm going to write the slope of the next slope of this signal, it is going to be 2r, because it is a slope, because it is a ramp signal having a slope of 2, and it starts at -1. Remember, this behavior is starting somewhere here, so it will be t plus 2, sorry, at -1, so t plus 1, right? So this will be the behavior of this equation, right? So I'm going to add this next piece of the puzzle into the picture. So next piece will be twice r of t plus 1, right? Now we are going to notice the third behavior, the fourth behavior or the next behavior into the signal. And let me use a different color so that we understand it. So next behavior is something like that. If you notice, the signals was somewhere here at this point. Now signal has dropped to this point. But if you notice the next continuing behavior, let me show you the behavior. Behavior is this one, right? It is again a slope, but there is a deep shift in the amplitude, and that shift indicates which singularity function. It is basically a step signal, because step signal provides you decrease and increase in amplitude, right? So this specific behavior is what? This specific behavior is u of t, is a step signal, right? And if I'm going to write that step signal is a amplitude of -2, because amplitude is decreasing from let me use a different color so that yeah, that is basically -2 u, and it happens at t equals to 1, so it will be t minus 1. Remember that at positive time indexes or delayed versions, we actually shows them with t minus 1, and advanced versions are indicated with plus sign to t plus 1, right? So this is a unit step, and this happens at what point? At t equals to 1. So if I'm going to add this signal into the picture or into the grained sum up example, so that would be basically -2 u of t minus 1, right? Now let's talk about the next behavior. The next behavior is somewhere here, as we were actually understanding it, that it's this behavior, this slope, right? And this slope is how many vertical units and how many horizontal units. So slope is basically what? Horizontal unit is 1 and the vertical unit is again 1. So slope is basically, if I'm going to write vertical units 1 over horizontal units 1, which means +1, right? Because it is increasing. So last slope was basically what? +1, remember? And this slope is basically what? +1. So there is no change in ramp. There is no change in slope. So that is why this behavior will automatically generate, because there is only shift in amplitude or decrease in amplitude, which is basically due to this u of t. Now let's talk about the next behavior, and let's use a different color so that we actually can understand it. So the next behavior is this one. So at this point, the slope was what? +1, and now slope is what? There is no slope at all. So slope is basically 0. So that means it is going to happen. Something is 1, and we are going to make it what? 0. So what we need decrease of -1. And remember, we are talking about slope. So we need a slope of -1 at this point. So a slope of -1 will be added at this point, and let me just add it for you here. So that would become minus ramp at what point? T plus 2, right? T equals to 2. So that means T minus 2 will be used, right? And that is the behavior of this part. So I'm going to include this behavior in the main equation that we are basically trying to make. So that is basically minus R of T minus 2, right? And then what is the next behavior, right? So if you notice here, the next behavior, let me use a different color again. So the next behavior is this one. Again, decrease in amplitude. And that decrease in amplitude is always generated by step signal, or increase in amplitude is generated by step signal. So basically, this is going to be a unit step signal, right? But that u of t is not simply u of t. It is basically at point t equals to +3. So it will be delayed by 3 units. And this decrease in amplitude is around 2. So that will be -2, right? So this part will indicate this specific decrease in amplitude, right? And we are going to add this specific thing in our main equation, and that is going to be this one. minus 2u of t minus 3, right? Because it is a decrease in amplitude of 2 units, and at a specific point t equals to 3. So it's a step signal which will start at around t equals to 3. So that's how you actually can express a signal into singularity functions, or in terms of singularity functions. So if you notice, this complete equation is basically reflecting towards this graph of the signal. So this signal can be expressed in terms of either ramp and unit step using this equation. I hope you have understood this concept of expressing any signal into. I hope you understand this concept of expressing any signal in terms of singularity functions. The most important point, I again repeat, this concept requires the depth of the knowledge of singularity function as well as of the time operations. So still, if you have any query, you can post your queries in comment section. Thank you so much for listening.